Okay, let's start. We're going to see about the JMS system or Java Messaging Services, Java Messaging System that's offered by WebLogic today. First of all, we will see what is JMS, why anybody would need JMS. Then finally, we will see how WebLogic provides such service. Now, JMS in general, for example, any two applications communicating with each other. Normally what we do, let's say you open up a browser and then you hit a URL. Now that kind of communication that we see is the browser is waiting for the response from the server, usually in this case a web server. Now that communication is a synchronous communication. Now as opposed to synchronous communication in all, many of the enterprise applications, it is not necessary that a calling application has to immediately get a response. For example, let's say you are depositing money in a bank. Now, the application that the bank teller is using actually rises some kind of message or something. The message which has the information of what account you have deposited into and then what's the amount you have deposited into. Now that information usually gets updated in a database. Now in this scenario, the calling application, which is the bank teller is using, need not wait for a response whether it's updated in the database or not. It's kind of a calling application can simply raise a message with all the details of the amount that you are depositing, and then there could be another application on the back end that is picking up this message and updating the table. So normally that's why you will see sometimes the bank says the update will take a couple of minutes. So there are two applications. So the first application is simply generating a message. A second application is the one that is actually putting the message into the database. That's when your money gets updated into the bank account. Now here, as opposed to the teller application directly contacting the DB, what we have done is we have decoupled the teller application from a database. In this case, even if the database is not available for certain time, the teller application has no direct impact. So the teller application in this case is not waiting for a response, immediate response from a database. Now there are lots of such requirements in our enterprise applications where one message sends a request or sends a message, but it does not necessarily wait for a response from the called application, or probably it's not even needed a response sometimes. So there are situations where what we need in this case is asynchronous communication. So you will usually see two types of communications everywhere: asynchronous communication versus synchronous communication. In asynchronous communication, both systems need to be present, which means the calling application and the called application, they have to be present at a time. The called application is expected to send a response immediately. So here if you say, let's say we are calling, this is one application calling something, and this is an application that is called the green box. So the calling, the red box, is waiting for the green box to respond immediately. That's a synchronous communication. Now, as opposed to synchronous communication, if the red box does not expect a response immediately from the green box, that's an asynchronous communication. Normally, when an asynchronous communication is implemented, these two systems need not be present at a time. For that thing, usually what we do is we put a message handler in between, or a message storage. So what happens here is the calling application simply generates a message, puts it into the JMS. The called application, this one, picks up the message from the JMS system. So here if you say, now these application 1 and application 2, they don't know about each other anymore. We have successfully decoupled these systems. They don't talk directly to each other. What you have here is a JMS system in between that makes sure the application that the message that the red box has generated will be delivered to JMS. When the green box is available, it will pick it up from the JMS. So the need for JMS, or when you use JMS, is when you want to implement a synchronous communication mechanism. All synchronous communication, you don't need to have anybody in between, because synchronous, a red box is waiting for the green box to respond immediately, like a browser looking for a website page. That's a synchronous communication. And asynchronous communication is like you sending an SMS, let's say, to one of your friend's mobile phone. Now your friend's mobile phone, if it is down, the message will still go out of your inbox. It will be stored on some central server, and then once your message, your friend's mobile becomes available, it will pick up the message from the inbox. So that's asynchronous communication. So in all our enterprise applications, there is always a requirement that somebody generates a message, a lot of people consume that message. For example, let's say you are working on there is a eBay website. When somebody makes a purchase, something like an event or a message is generated with all the details of the purchase. Now that message will be consumed by a lot of other ongoing systems in the pipeline. It will be consumed by order management system, it will be consumed by a CRM, it will be consumed by a dispatch system, it will be consumed by a feedback system. So a message can be consumed by a lot of other people, a lot of other applications. So that consumption is not necessarily need to be known to the application that is generating that message. So in normal enterprise applications, to summarize, you will need synchronous versus asynchronous communication. Synchronous is when you need both the applications to be available at a time. They are talking to each other directly. Whereas asynchronous communication, they are not talking directly anymore. A second application is available somewhere, the first application is available somewhere. The first one does not know anything about the second one. First one simply generates a message, puts it into a JMS system, the Java messaging system. A second application picks it up from the Java messaging system. Now that way you have successfully decoupled first and second applications. Now here, what is JMS? There are a couple of things. So JMS is a set of specifications for asynchronous communication. So as I said, the moment you think of JMS, it's asynchronous. You won't have synchronous and you won't need JMS in that case. Now this is a part of your JEE specifications, just like any other specifications, Java Enterprise Edition specifications. The specifications tell us how to implement a JMS system, means how to make two applications talk to each other. Our WebLogic also implements those specifications. WebSphere also implements those specifications. TIBCO is there that implements the same set of specifications. MQ, whereas WebLogic and WebSphere are regular application servers that will give the basic JMS. You have TIBCO, MQ, they are the actual enterprise level JMS systems, like they are called enterprise message systems, EMS systems. So they provide all the high availability features, failover features for implementing asynchronous communications. They're usually called buses. So normally in any typical environment you will see WebLogic or WebSphere which has an application deployed on them. That application generates a message, then it will be put into the JMS system, basic JMS system provided by the WebLogic or WebSphere itself. That will be moved on to an enterprise JMS, a TIBCO or MQ. So from WebLogic JMS we move the message to a TIBCO JMS, and from there it will be distributed among a lot of other applications. So you have WebLogic or WebSphere, the basic JMS, and then TIBCO, MQ, all the other things that enterprise or advanced JMS things. Now some of the examples that we've been talking about, what would be a JMS way of communication. Let's say a banking application wants to send a SMS alert after you withdraw money from your account. Now obviously the SMS sending application is a mobile provider, whereas you walk into ATM is a bank application. So the bank application is using a mobile service provider to send the SMS. Now if the mobile service provider application is not available when you are withdrawing the money, it should not be the case that you cannot send the message anymore, or the bank application or your ATM application should not keep waiting for the mobile application to be available. In that case what it does is, your ATM or your application that is used for withdrawing the money simply generates a message and puts it into a JMS system. Now the JMS system is the one that stores the message. Once the SMS sending application becomes available, that will pick up the message from the JMS system. It will send it to your mobile number. So if you see a flow, typical flow, JMS is an internal subsystem that can store, and it can also guarantee the delivery of the message from application 1 to application 2. Now in a typical flow you will see application 1 sends a message to a JMS system. Now the JMS system stores the message in whatever order they have arrived. The order is very important. JMS preserves the order in which they have arrived. If application 2 is available during that time when the message arrived, it will be delivered. If app 2 is not available at that time, then obviously it gets stored in the JMS system itself. Again, when application 2 becomes available, it will be delivered. Now here, if in this case, one thing we must remember is, we always say app 1 sends it to JMS, JMS delivers it to app 2. Even though we say this thing, the sentence is little different. App 1 sends it to JMS, app 2 picks up from JMS. JMS system, I will elaborate it. I'll give you an example. JMS system is like a post box, let's say in your apartment or at your house. Now the postman comes down and he puts the letters in your post box. Then a post box is not coming to your home and delivering it to you. You go to the post box and pick up the letters. So post box is just a storage system. Your JMS is exactly the same thing. JMS takes the message given by the app 1, which means app 1 is going to JMS giving the message. Now JMS is not searching whether app 2 is available or not. It's app app2 when becomes available will come to JMS and will pick up the message. So JMS system is just a passive system. That's what it's usually called. It's not an active system. It's not something like it polls for application 2 available or not. It doesn't. JMS is not bothered whether application 2 is available or not. If app 2 comes and asks for a message, then only it gets delivered. If nobody asks for it, yes.
So basically, does it mean that the app 1 and app 2 have to be kind of compatible, or have to have some kind of a setups in place so that they can send and receive the JMS messages? Or in simple terms, maybe app 1 and app 2 has to be JMS enabled.
That's right. That's right. Yes. They have to be programmed for sending JMS messages to JMS systems. They have to be programmed to receive. I mean, they have to program to go to a JMS system, pick up the message. It's usually done in MDBs, message-driven brains in Java. So your entire JMS programming is done using MDBs. They have to be JMS enabled. That's correct. So here, JMS is a passive system. Basically, app 1 sends a message to the JMS, app 2 goes to the JMS and picks it up. JMS is simply a static system available there. Now your app 1 and app 2 have to be enabled, or should be capable of doing such a thing. They should be capable of going to JMS system, deliver a message. Then the same way they should be capable of going to a JMS system, pick up the message. This is usually called, this capability called subscription. Every application subscribes to JMS system. Application 1 subscribes to JMS system so that it can send messages. Application 2 also subscribes to JMS system so that it can receive messages. Now this entire subscription mechanism in Java is implemented using what is called message-driven beans. Now again, so the main purpose, to summarize whatever we have talked so far, JMS is required for asynchronous communication, point 1. And point 2, JMS is a passive system. Means it simply picks up the message. When somebody asks for it, it delivers. If nobody asks for it, it will be lying there in the JMS. After a certain amount of time, it will expire. The message will expire and it will be discarded. And JMS maintains what is called a FIFO order, first in, first out order. Means the message order in which they arrived is what the message order in which they will be delivered. Now here, inside the JMS, there are two scenarios we usually come across for every message that is received. When a message is received, you will have scenarios where the message can be consumed by only one receiving application. That's one scenario. The scenario in this example is, let's say I've given it, let me give you an example. So let's say you have a bank. Now a bank has a lot of branches like this. Now when a bank has a lot of branches, the bank has given us a provision, you can go into any of these branches, you can deposit money. Now the data is actually stored in a database, somewhere in a database like this. Alright, all the bank accounts or all customer information is stored in here. The bank implements such a mechanism. This is a teller application you are looking at. Once you deposit some money, it generates a message which gets stored in a JMS system. Then there is another application, app2, on this side, that picks up this message, let's say M1 here, right? M1 here. This application picks up this message, and then it updates this database. So here what we have here is, this is the setup we have. These are all bank branches. All the bank branches are using the same application. When somebody walks in, deposits the money, the bank branch application or the teller application does not directly connect to the database. It generates a message, M1 puts it into the JMS system. Then there is another application, app2. The app2 picks up the message, executes an SQL query so that your balance in the database is updated. Now this is a typical setup, let's say. Now in this case, what happens is, there are lots of branches, so there are lots of messages. So M1, M2, M3. Now to handle such a load, you will need not just one app2, but lots of instances of app2. For the sake of simplicity, let's say app2 is a Java application. Because it's a Java application, assume we have deployed it to a lot of managed servers, so that those managed servers can handle the load of messages that are coming in. So here there are a lot of messages getting generated every second, let's say. A lot of messages, a lot of people are depositing money. Now whenever somebody deposits money, a message is generated. Now basically this single application is not able to handle all these messages. So what we have done is, we have deployed the same application onto multiple instances of WebLogic. All of them doing the same job. They simply pick up the message. All of them same too. They pick up the message and then they go to the database, update it. Now here, what happens is, if M1 is picked up by app2, it updates it. The same M1 again should not be delivered to another instance of app2. Means, let's say these are all managed servers. Managed server 1, managed server 2, managed server 3, managed server 4, like that. Managed server 1 picked up M1, updated in the database. So you have got your money. Let's say you're depositing some 50k. You got your money into your account plus 50k. Now if M1 is delivered again to app2, or a managed server 2 instance, this also running the same application will try to add 50 more. That's what is going to happen. We are happy there, but the bank is not. So here we have a situation where each message should be delivered only to one instance or one application, and immediately this message should be discarded. So that's a requirement here. So this is JMS, pure JMS, but even in JMS there is a requirement. My M1 message should be delivered only once. It should not be delivered multiple times to multiple subscribers. Now once that update is done, let's say you are getting two types of alerts. Now when the message application 2 updates the table, it generates another message. This is another JMS system. So here if you see, again same other JMS system. App2 generates another message. This is for your alerts. Let's say you have subscribed for two types of alerts. One is SMS alert. You have also subscribed for email alerts. Means whenever you deposit money in your bank account, you will get an SMS. You will also get an email. Now if you observe, the content of both these alerts are usually same. You will see both the alerts same. It basically says you have deposited X amount, or X amount is credited into your account. The current balance in your account is Y. The same message you will receive both on your SMS as well as your email. So what we are expecting here is, as opposed to M1, we are expecting M10 to be consumed by an SMS application, which is this one, and also we are expecting this to be consumed by an email application. Now the message that was generated here, M10, will have three fields. Let's say it will have name, or the message body, to be precise, message body. After the message body, it will have a mobile number, and then it will have an email ID. So M10 has three fields. It has message body, mobile number, email ID. The expectation is M10 gets consumed by two types of applications. One is an SMS sending application, which will use the first two fields in the message body and the mobile number, and sends you an SMS. The same message gets consumed by email sending application also. The email sending application uses the first and the third fields, message body and email ID. So here, this is completely contrasting to how our initial JMS worked. The initial JMS system, we expected M1 to be consumed only by one subscriber, or every message is delivered to only one. Whereas in another scenario, this is also again JMS, this is also a synchronous communication. Here SMS application and app2 has no role, no direct communication. This is also asynchronous. But in this JMS, we are expecting the message to be consumed by multiple receivers. Now these are two types of communications you will see in all JMS. Depending on what type of requirement we have, we may want what is called a one subscriber versus multiple subscribers. Now the one subscriber that we have, let me just copy paste it somewhere. So those are the two types of communications. One, you have one subscription. Second one, we have multiple subscription. Now the first one is called usually a point-to-point communication. Point-to-point communication in the sense there is one and only one application that can receive the message. M1 can be received only by one receiver. As opposed to that, we have seen M10, which can be received or which should be received by multiple applications, both SMS and email. Now that is called a publish subscribe communication. So every JMS implementation can implement one of these two. There are two types of JMS implementation. One is point-to-point communication, other one is publish subscribe communication. These are the two types of JMS communications you will see. Both are asynchronous, remember that one. JMS is asynchronous. In this case also, both are asynchronous communications. The first one will deliver it to only one subscriber. The next one, or the publish subscribe model, will deliver it to multiple subscribers. Now what we're going to see is how WebLogic implements these two types of communications, or in general how WebLogic implements the JMS system itself. Again, going into a little bit elaboration, this is a point-to-point communication, single consumer. Now a single consumer mechanism is usually implemented using a queue. This is not just for WebLogic. Any JMS product, WebLogic, WebSphere, TIBCO, MQ, anything you take, the same fundamentals will apply. They don't change. In this case, if your JMS has a requirement that we have to implement a point-to-point communication, point-to-point is you have a single consumer. This is the most important thing. It's a single consumer in the sense the message will be delivered only to one consumer. That is implemented using a queue. Now as opposed to a queue, the other thing you would have is a topic. Our topic implements what is called a publish subscribe mechanism. The client which generates a message publishes the message to the topic, and the client which wants to receive the message will subscribe to the JMS. So in the JMS you got queue, which implements a point-to-point mechanism.